Okay, we're ready to do the Unit 5 review for the Math 4 course. And yeah, I've been in classes like that. All right, we're supposed to identify all of the different changes to the parent. In these two cases, it would be y equals sine of x would be the parent. And we see the negative, which means that there's going to be a flip. Whoops, I'm going to turn the pen on. A flip on the x-axis. The 3 means an amplitude of 3. The negative 4 means a shift of down 4. And then we're going to have to come over here and figure out if my period is 2 pi over 6. That's going to be a period of pi over 3. Right over here, I've got an amplitude of 9. Shifting up 1. And then pi over 3 is basically saying 1/3 pi. So if I do this with 1/3 underneath, that is the same as flipping and multiplying. So that's going to give me a period of 6 pi. Okay, here we have an amplitude of 2. We are going up 8 units. And then over here we're saying 2 pi over that 5 in front of the x. That's not going anywhere. So we're just going to say 2 pi over 5. If you said 2/5 pi, that's fine. All right, here the negative means that we're going to flip on the x-axis. We have an amplitude of 7. We're going down 3. And our period x over 5 is going to be like 1/5 x. And so for me to say 2 pi divided by 1/5 is the same as 2 pi times 5 over 1, and that's going to be a period of 10 pi. That's a big wave. All right, now we go the other way. Here's the descriptions, and we have to write the equation. So we're reflecting across the x-axis. We're going to start with a negative. There is no mention of amplitude, so it is presumed to be 1. Our period is 4 pi, which means 4 pi equals 2 pi over b. And I always like to think of it as, well, we could do the rule that I've taught before in geometry that I call switcheroo. Anytime that you have a number on the left and then you've got a fraction on the right and your x is the guy on the bottom of the fraction, all you have to do is switch the b and the 4 pi. Now by the time I reduce that, that's going to be 1/2. So that's going to be 1/2 x. You could say x over 2. And then the shift of down 2 is going to do that on the end. All right, this one we have no flip. We do have an amplitude of 9 in front of the cosine. Our period is 2 pi, which means there's not really any change in b. So that's going to be cosine of 1x, and then shift up of 7. Okay, 2 more down here. We have no flip, but we do have an amplitude of 3/4. That is the sine. And if the period is 6 pi over 6, well, let's see, now if I were to double that, I'm going to be doubling that. That would be like 2 over 12. So b is going to be 12x, and then shift up 1. You cross multiplied it, you get bx, or b pi equals 12 pi, which means b has got to be 12 anyway. Okay, here we've got a reflect across the x-axis. We have a no mention of amplitude. Period is pi over 4. If I cross multiply, I get 8 pi and b pi. I guess b must be 8. And then we shift up 5. All right, more of the same. I'm going to start with that. I have no flip, but I do have an amplitude. And I have sine, a period of pi over 6. B pi equals 12 pi, so B must be 12. And then shift up 1. Reflect across the x-axis. No amplitude mentioned, but there is a cosine. Period of pi over 4. So b pi equals 8 pi. B must be 8. All right, before we graph it, let's take inventory. We've got a negative up front, which means that we are going to flip on the x-axis. Our amplitude, there is no number in front, which means that our amplitude is 1. We can say that our shift is going down 2. And then for the 2/3, it's going to be 2 pi over 2/3, which we're going to flip and multiply that. That's going to give us 6 pi over 2, or 3 pi. So we are, let's see, we are shifting down 2, so we need to mark that first. Since this is the sine, we're starting right on the midline. And let's see now, we are flipping, well, first of all, our period is 3 pi, so we're going to stretch all the way out to here. We're going to cross it halfway. But instead of going up and down, we're flipping on the x-axis, which means we're going to go down, amplitude of 1, and going to go up, amplitude of 1. And then we can finish that out. Something like that. Let's try the other one. Here we have an amplitude of 2. We're going up 2. And then our period is 2 pi over that 2 in front of the x, which is going to be pi. We're going up 2, which means I got to shift everything. All right, now our cosine does not start from the midline, starts at the amplitude, which our amplitude is 2. Our period is pi, which means that we're going to go down and back up again and finish up here at pi. Now the halfway point is the bottom of the bowl. We went 2 units up, we're going to go 2 units down, which means we're going to cross there. And then on my halfway points, something like that. Come over here. Something like that. All right, now this is something that is going to happen on this test, is that you're going to be given an equation, a graph like this, and you're going to have to figure out what's, well, I guess they didn't say, they just said find. But in the case of the test, they're going to ask you to write it as an equation. All right, amplitude. Before we do amplitude, we need to know where the midline is. Where's the midline? Well, this thing travels from -2 all the way up to +6. And so halfway, that's actually traveling 8 units altogether, which means I'm going to go 4 units from either one. That means my amplitude is 4 up and 4 down. Well, that answers a couple of questions. Amplitude is 4. My shift is up 2. Now what we need to do is figure out the period. Now this thing starting here and ending there looks very much like a cosine. And our period appears to be 2 pi. So we can just mark it as such. Now, just to get you in the habit, this is going to look like 4 cosine x plus 2. I've got the amplitude of 4. My period of 2x means that I'm going to have basically 1x in front of after cosine. And then the shift up of 2 is going to be the plus 2 on the end. All right, let's tackle another one. This one went from 3 to -3, which means that there is no shift. It is right on the axis. So amplitude means that we went 3 units up and 3 units down. My period, I started here, I went up and down and back up again. My period is 6 pi. And there was no vertical shift, there was no other transformation, so that's pretty much it. Now the issue becomes, how do I write it as an equation? B, that cross multiplying, that's going to be like 6 pi b and 2 pi. If I have 6b pi equals 2 pi, 6 times what would give me 2? B would have to be 1/3. 6 times 1/3 would give me 2. So my equation is going to look something like this. And there is no vertical shift. Okay, number 13. Let me see where we are in the midst of this. Yeah, we're actually not that far from being done, so let's go ahead and finish this. Let's see now. You went from 3 to 1, which means that your midline is actually right there. So our shift is going to be up 2. Our amplitude seems to be 1 unit above, 1 unit below. This seems to be a cosine rather than a sine. And our period appears to stretch from 0 to 4 pi. And if we said that 4 pi equals 2 pi over b, cross multiply, I get, well, actually what you would get, you could use that switcheroo tool that I've taught you about. B equals 2 pi over 4 pi. That would actually reduce down to 1/2. That gives me an amplitude of 1. B was 1/2, and then plus 2 for the shift up 2. All right, one more. Here I'm going from 4 to 0 to 4 to 0. So my midline must be at 2. So I've just shifted up 2. My amplitude appears to be up 2 and down 2. There is no flip. So the only thing left is to figure out the period, which the period appears to be from a cosine starting point, and it goes from 0 to pi over 2. Now that's going to be period equals 2 pi over b. So when I cross multiply, I get b pi and I get 4 pi. So b must be 4. Amplitude of 2, this was a cosine. We said that b was 4, and the shift up was 2. Okay. All right. This one we needed to talk about for a minute because I realized that I tossed you a fastball on this one. One of the first issues was that as far as the x-axis is concerned, you have to think that you're going from December 1st to December 2nd to December 3rd. You're doing it 24 hours at a time. So by the time you get from midnight December 1st all the way to the end of December 3rd, you've done 3 days times 24 hours a day. That's 72 hours. That's what this should look like. What I wound up doing was to convert this to decimal, and that was the other thing I made the suggestion here, convert it to decimal. Well, 6 divided by 60 is 1/10. 57 divided by 60 actually winds up being 0.95. Now 1600, that's 4 o'clock in the afternoon. And that's going to wind up looking like that. 2215 is going to be 22 hours and let's see now, that's going to be 2:05. Well, 15 minutes is a quarter of an hour, so that makes sense. But now the next day, December 2nd, we've already been at this for 24 hours. Plus the 442 is going to be 28. And 42 winds up being 0.70. And 24 plus 10 equals 34. And that's going to wind up being 0.27, something like that. One of the first ever jobs that I got was in a company that would go around and clean offices at night. And so my job was to go in and dust the desktops and vacuum and change out the trash cans and clean up the bathrooms and all that kind of thing. And it was the most unique thing because their time card had was done by the 10th of an hour. Every 6 minutes was a 10th of an hour. And, if I worked less than 3 minutes, then I would round down. And I've worked more than 3 minutes, I'd round up. So for instance, 6 minutes would be a 10th, 7 minutes would be a 10th, 8 minutes would be a 10th, 9 minutes would actually be 2/10. and 10 minutes and 11 minutes, and then 12 minutes would be exactly 2/10. But I would round my time card up and down, so I actually got pretty good at knowing where the different times were on the clock and how they would create a decimal. But that's something you could do with a calculator. Um, December 2nd, 442, you would say 42 divides 60 and you would get 0.7. And so that's, and 24 hours added to the 4 hours inside December 2nd. Anyway, so that's how you would convert that. Now, let's see how that's going to turn out. All right, so we've already had this discussion, and so the different times, 406, 957, 1658, 2215, all look this way as decimals, and then these are the heights of the tide that go along with them, and so this is what you would plug in as your T chart, your X and your Y table, and so let me leave that there for a second. As far as those of you that are having problems converting from hours and minutes to hours with a decimal. But anyway, all right. So once we plug in this, we see that we have an R squared of 0.984, which looks really good. And look at the graph. I mean, the numbers are practically up against the graph. Now, I will notice something that curiously happened. We had like 4 highs and 4 lows each day. So that was 8 highs and 8 lows altogether. And when I started looking at what was happening on the graph, I started noticing that a weird thing was happening. That it's like every other peak would either be just above, just below, just above, just below, just above, just below. And it happened that way with all 8 of the highs. And I asked myself, is there a reason for this pattern? Well, if you consider it for a second, why would my first high of the day be slightly above and the second high of the day be slightly below? I'll let you pause, and then I'll tell you what I'm pretty sure the answer is. I'm pretty sure the answer is because of the fact that the high tides happen as the moon is closest to us directly overhead, and then the moon is closest to us directly behind the planet, so to speak. Because when it moves around the sides of the Earth, that's where we get these other wiggles. But I'm pretty sure that the high tide above would represent where the moon is actually. We can see the moon up in the sky. But this one where it dips underneath it is probably where the moon is completely on the back side of the planet. And, the gravity is pulling the tides in a different way. But anyway, so we get an equation out of this. But more importantly, we have a graph that we can trace. Because the next question was, so what about, I'll scroll back up to make sure my memory is straight, December 5th, 7 a.m. All right, so you got to think about it. December 5th, 7 a.m. You have the first, the second, the third, and the fourth. That's 4 days times 24 hours. That's 96 hours for the entirety of December 1st, 2nd, 3rd, and 4th. But now you're in December 5th at 7 a.m. So that's going to be 96 plus another 7 hours. That's 103 hours after you started this graph. So what you are looking for is where X is 103. And when you find that, you discover that the height should be about 0.5. Most of these readings were to 2 decimal places. So I would say that the tide would be at 0.50 height, feet. I'll clean that up. All right, so that's the anticlimactic ending to that one. Now let's look at the other one. Daylight hours in Nome, Alaska. I actually Googled this. And this represents how many hours and minutes they have of daylight hours on the average during the month. Now, if you think about it, if this is the average for the entire month, then it's a reasonable guess that this might have been the actual time for the 15th of the month. So if I register my X as 1 for January 15th and 2 for February 15th and so on, then what I'm doing is I'm putting this on the curve where the 15th of the month falls on 1 and 2 and 3 and 4. So let's do that first. Our table should look something like that. And that's what your graph should look like there on the right. And we're getting an R-squared value of 0.995, which is really, really, really good. Which tells you that this is definitely a sinus pattern. So the question becomes, let's see, what do you do with October 1st? All right, well, when you think about it, let's play with this for a second. All right, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 would represent October 15th. 9 would represent September 15th. If I want October 1st, that is probably 9.5. So that's what we're going to chase on the graph, is where did 9.5 land? And as it turned out, and that was about 11.511 hours. It's about 11 and a half hours. And I do promise you one of these on the test. I think I'm going to be nice and just leave it at 1. But, where you'll have to plug in the data and then find, so what's the projection on this placed on the curve. So that should get you ready for the test.